Hey folks, Peter Cross from AMD here. In today's Quick Bytes segments, I want to show you how easy it is to get up and running on AMD's ROCm. What is ROCm exactly? Well, I'm glad you asked. If you think of Instinct GPUs as high-performance racing cars, well then ROCm is the equivalent of high-performance jet fuel that allows you to squeeze every ounce of performance out of those Instinct GPUs. It's similar to CUDA, and in fact, for most applications, you can simply drop ROCm in as a straight CUDA replacement with little to no code changes required. And with that, let's get started with ROCm installation.
First, we'll need to install DKMS kernel headers and modules for my version of Ubuntu. Then we'll download the actual installation package. For this example, we'll be using the AMD GPU installer. Now, as we go through some of these steps, I'd like to take a little bit of time to highlight some of the new changes in this version of ROCm. First, we've extended VLLM support in ROCm 6.2, helping to advance AI inference capabilities of the AMD Instinct accelerators. Also, we've added bits and bytes quantization support for enhancing AI training and inference on AMD Instinct by boosting memory efficiency and performance. Now coming back to the installation in process, I'd like to highlight how you can tailor the installation to specific use cases. First, we listed the use cases that are available, and then we specified specifically which use cases we wanted to focus in on for the installation. This process really allows you to optimize performance for your specific workloads. You may have noticed during this install there are a ton of ROCm libraries and tools that are being installed. Right now I'd like to highlight a few of those. In support of AI, you have the composable kernel, MIOpen, MIVisionX, and the communication library is called RCCL, or RCCL for short. There are a number of linear algebra and matrix operation APIs that are covered by HipBLAS, HipSparse, ROCBLAS, ROCsolver, ROCWMMA, and just a ton of others at your disposal. Also important is the HIP libraries. HIP stands for Heterogeneous Computing Interface for Portability, and it's a C++ runtime API dialect of ROCm that allows developers to write portable code for both AMD and NVIDIA GPUs. And lest we forget is one of my favorite features in ROCm, the Hipify tools, which are tools that automatically translate NVIDIA CUDA source into portable HIP C++. The ROCm Docs website and associated blogs are a great resource for learning how to implement these libraries and tools into your respective projects. Our plan is to devote a number of these future Quick Bytes segments to showing how to leverage ROCm's APIs and libraries for AI workloads, so stay tuned for those. As we start to wind down the ROCm installation, we'll turn our attention to some post-installation steps. Here's where we'll configure the system linker and set up environmental paths for the ROCm platform. Lastly, we'll show a few commands to help validate that your installation of ROCm was successful. The most important of these tools will be the AMD System Management Interface tool, or AMD SMI. This tool replaces the ROCm SMI tool, and it will allow you to control and monitor all AMD resources on your system. Please refer to the ROCm website for any steps you may have missed during this presentation. It will allow you to dive deeper into just about every topic that we covered today, as well as cover installation steps for other flavors of Linux besides Ubuntu, which was used for today's demonstration. Thank you, and see you in the next Quick Bytes episode.